Alright gang, so here we are on one of our last flip lessons of the year. This is going to be about geometric sequences and series. You see we have a lot to go over, but it should be a pretty quick video because none of it is all that complicated. So last time we talked about arithmetic sequences. Today we're going to talk about geometric sequences and also geometric series, and they're basically connected to each other. So arithmetic sequence had to do with a common difference. We were adding the same thing every time. Geometric sequence then is just product. We're going to have a common ratio, meaning we're multiplying or dividing by the same number every time. A geometric series then is just the sum of an infinite geometric sequence. So first piece, if we want to find the common ratio of a geometric sequence, we just need to divide any term by the previous term. And if it's geometric, they would all be the same. So we could say 12 over 3, or 48 over 12, or 192 over 48. All of those would give us a common ratio of 4. So arithmetic difference we subtracted, geometric sequence we divided. So here, be careful on this one because a lot of times people say 2 because 6 times 2 is 12, 3 times 2 is 6. But really, remember, you need to take one term divided by the previous term. So it would be 6 over 12 or 3 over 6, and those are going to reduce to a common ratio of 1/2, meaning we're getting half as large each time we see them here. If we wanted to write a series of terms, we're just going to apply the same way we did the common difference previously. Now we're going to apply the common ratio, but instead of adding, now we're going to multiply. So a sub 2, we take 3 times 5 would give us 15. A sub 3 then would be 3 times 15 is 45. And a sub 4, we do the same way as 3 times 45. Another example here then, a sub 2 would be 24 times 1/3 or 8. So you see we're reducing now. A sub 3, we'd get 8 times 1/3 or 8 over 3. And then we could do one more for a sub 4 and so on and so on. Okay, next piece then, if we had a general formula, if we were going to come up with a general formula, a sub n tells us a general term is always going to be your first term times whatever your common ratio is to the n minus 1. So if we're writing this, we always need our first term and the common ratio. So here you can see in this first example we know the first term, and we can find our common ratio by saying 12 divided by 2 is 6. So our general formula here, a sub n would equal 2 times 6 to the n minus 1. And that would give us our common ratio every time, or that would give us our general formula, sorry. Next one a little more complicated. You see a sub 1 is 5, but now our common ratio is negative 1 over 5. And so our general term, a sub n, is going to equal our first term, and this one you're always going to need to make sure you put this in parentheses, negative 1 over 5 to the n minus 1. Always make sure you put that in parentheses because the sign is going to change, and you can even see that in your sequence here because it's flipping back and forth. Okay, so the last two things we have then is to talk about the sum. We can either have the sum of a finite sequence, meaning there is a set number of terms, or the next one we'll talk about infinite. So for finite we have this big ugly formula. And so if we're trying to find the first 12 terms, that means we're trying to find s sub 12, and that is going to equal a sub 1, which is 2, times 1 minus, we need r, and you can do that. 6 divided by 2 is going to give us 3. So 3 to the n, which is the number of terms again, over, or 3 to the 12th, and then the whole thing over 1 minus r. Okay, as long as you plug that into your calculator carefully, really just like you see it there, you shouldn't have any problems. And for this one, we're going to get 531,440. Okay, 531,440 would be the sum of the first 12 terms of this. Now for an infinite geometric series, first thing we can only do it when r is in between negative 1 and 1. So if we get bigger than 1 or less than negative 1, you can't find the sum. The sum is either going to go off to positive infinity or back down to negative infinity. It only works when r is between 1 and negative 1. And it's a little simpler here. We're just going to take a sub 1 over 1 minus r. So the sum of this series, you'll see that r is 1/3, because we're multiplying each one of these by 1/3. So we're just going to say our first term 1 over 1 minus 1/3 And if we added all those up, all infinite of those, we would always come to 1.5 units. Okay, so there were several different types we did there. 2 sum formulas you're going to have, and then your general formula for a geometric sequence are probably the most 3 important things. A geometric sequence, remember, has a common ratio, which means we multiply the previous term by that common ratio to get the next term. See you next time.